In this video, we're going to be solving a quadratic equation using the quadratic formula. The quadratic formula, which we proved in a previous module, is x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And the discriminant is the expression b squared minus 4ac. In 1, it says, use the equation 9x squared is equal to negative 12x minus 4 to answer parts A through C. In A, it says write in the form ax squared plus bx plus c is equal to 0. So we want to move all of our terms to one side of the equation. So we're going to have 9x squared plus 12x plus 4. And we got that by adding 12x to both sides and adding 4 to both sides. And now it's equal to 0. And in B, they want us to define A, B, and C and find the discriminant. So we're going to have A is equal to 9, B is equal to 12, and C is equal to 4. And now we're going to use the discriminant. So B squared minus 4ac is equal to 12 squared minus 4 times 9 times 4, which is equal to 144 minus 4 times 9 is 36 times 4 is 144. So we have 144 minus 144, which is equal to 0. And then in C, it says solve the equation using the quadratic formula. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this is equal to negative 12 plus or minus the square root. And we solved b squared minus 4ac above, so we have the square root of 0 divided by 2 times 9. And because we have plus and minus the square root of 0, we're going to simplify this to negative 12 divided by 2 times 9 is 18, and negative 12/18 can be simplified to negative 2/3. And now it asks, how many solutions are there? And we had one solution. And then it asks, are the solutions real or complex? And we have real solutions. And then it says, is the discriminant positive, negative, or 0? And our discriminant was 0. In 2, it says, use the equation 1/5 x squared plus x is equal to negative 3/5 to answer parts A through C. And in A, they want us to write it in the form of ax squared plus bx plus c is equal to 0. So we're going to add 3/5 to both sides, and we get 1/5 x squared plus x plus 3/5 is equal to 0. And now we can multiply this equation by 5 so that we don't have to deal with fractions when we're using quadratic formula. So we have 1/5 x squared times 5 is x squared, and then we have plus 5x plus 3 is equal to 0. In B, they want us to define A, B, and C and find the discriminant. So A is equal to 1, B is equal to 5, and C is equal to 3. And now we want to find the discriminant, which is b squared minus 4ac, which is equal to 5 squared minus 4 times 1 times 3, which is equal to 25 minus 12, and that's equal to 13. And in C, they want us to solve using the quadratic formula. So we have the quadratic formula, which is x is equal to negative b plus and minus the square root of b squared minus 4ac divided by 2a. And this is equal to negative b, which is negative 5 plus or minus the square root of the discriminant, which we found was 13, divided by 2 times a, which is 1. And this is equal to negative 5 plus or minus the square root of 13 divided by 2. And now they ask how many solutions are there? And there are 2 solutions. If you look at this, because our discriminant wasn't 0 like in the first example, we have a number inside of our square root, and there's a plus and minus in front of it. So one of our solutions is negative 5 plus the square root of 13 divided by 2, and the other solution is negative 5 minus the square root of 13 divided by 2. And then it asks, are the solutions real or complex? And our solutions are real. And is the discriminant positive, negative, or 0? And our discriminant was positive. In 3, it says, use the equation negative x times x minus 6 is equal to 11 to answer parts A through C. And in A, it asks us to write in the form of ax squared plus bx plus c is equal to 0. And the first thing I'm going to do is distribute the negative x through the parentheses. So I get negative x squared plus 6x is equal to 11. And now I need to move all of my terms to one side of the equation. And I'm going to move everything to the right side so that my x squared term is positive. So I have x squared minus 6x plus 11 is equal to 0. And now they want us to define a, b, and c and find the discriminant. So a is equal to 1, b is equal to negative 6, and c is equal to 11. And now the discriminant, b squared minus 4ac is equal to negative 6 squared minus 4 times 1 times 11, which is equal to 36 minus 44. And this is equal to negative 8. And now we want to solve the equation using the quadratic formula. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this is equal to negative b, and we have a negative 6 for b, so we have negative negative 6, which is positive 6, plus or minus the square root of the discriminant, which we found to be negative 8, divided by 2 times a, which is 1, and this is equal to 6 plus or minus, and when we have the square root of a negative number, remember that the square root of negative 1 is I, so I'm going to get rid of the negative inside of the radical by factoring out the I, and then the square root of 8 can also be written as the square root of 4 times the square root of 2, and the square root of 4 is 2, so we have 6 plus or minus 2i times the square root of 2 divided by 2. And now I can simplify this one more time because each of our terms in the numerator are factors of 2, so we can divide each of them. So we have 3 plus or minus I square root of 2. And now they ask how many solutions are there? And there are 2 solutions. And then it says, are the solutions real or complex? And because of the I, our solutions are complex. And is the discriminant positive, negative, or 0? And our discriminant was negative. In 4, it says, based on problems 1 through 3, complete the following. The solutions to the quadratic equation ax squared plus bx plus c is equal to 0. So long as a is not equal to 0, our x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And then it says, if b squared minus 4ac is less than 0, there are two solutions which are complex, and if our discriminant is less than 0, that means we had a negative sign inside of our radical, and that's what causes our complex solutions. And then it says if b squared minus 4ac is greater than 0, there are two solutions again, but these solutions will be real. And if b squared minus 4ac is equal to 0, there is one solution, which is real. In 5, it says use the equation 5x squared minus 4x plus c to answer parts a through c. In A, it says find one value of c such that the equation has one real solution. So remember, in order for it to have one real solution, our discriminant must equal 0, and our discriminant is b squared minus 4ac, and we're going to set that equal to 0. And b is equal to negative 4, so we have negative 4 squared minus 4 times a, which is 5, times c, and this has to equal 0. Negative 4 squared is 16, and then we have minus 20c is equal to 0. And now I'm going to add 20c to both sides, and I get 16 is equal to 20c. And now we're going to divide both sides by 20. So c is equal to 16 over 20, which could be reduced to 4 over 5. So if c was 4/5, then our discriminant would equal 0, and we would have one real solution. In b, it says find one value of c such that the equation has two complex solutions, and it says answers may vary. And remember, in order for an equation to have two complex solutions, our discriminant must be less than 0. So we're going to have b squared minus 4ac is less than 0. And we found that b squared minus 4ac was 16 minus 20c, and this needs to be less than 0. And then when we add 20c to both sides, we have 16 is less than 20c. And now divide by 20, so we get c needs to be greater than 16 over 20, or c needs to be greater than 4/5. So we could choose any value greater than 4/5 as an answer. So we could say c is equal to 1, and this would give us two complex solutions. And that's all for our video on solving a quadratic equation using the quadratic formula.